Since the rise of generative AI, the demand for GPU chips has soared. NVIDIA's GPUs dominate the AI chip market. Meanwhile, tech giants like Google, Amazon, and Meta are not only using GPUs as AI chips, the race to develop custom ASICs is on. What exactly are ASICs and why are tech giants all rushing in? To understand ASICs, first grasp the ASIC versus General IC difference. General ICs are universal chips for many needs. CPUs and GPUs are typical examples. The CPU is the central processor, like a brain. It's responsible for executing various commands. The GPU is the graphics processor for images. GPUs excel at complex parallel math processing. This makes GPUs powerful tools for AI training. They have more diverse applications. Compared to general-purpose ICs designed for a specific purpose are application-specific integrated circuits, or ASICs, also known as custom chips. ASICs were popular in the 1980s, led by US and Japanese companies. For example, Nintendo's Famicom used a custom ASIC for game image processing. Compared to general-purpose ICs, ASICs require custom design for special needs. Their development costs are higher, and for specific uses, production is small. This further raises the unit cost. After 2000, due to the high barrier of ASIC customization, general-purpose ICs became the mainstream. Around 2010, breakthroughs in neural networks and learning sparked a new wave of AI enthusiasm. Tech giants like Google, Microsoft, and Amazon built data centers for higher computing needs. Besides using GPUs to train AI models, these firms also began investing in ASIC R&D, hoping to optimize their core services like search, voice recognition, and more. The most famous example is Google's TPU, launched in 2016. Because ASICs focus only on specific tasks, they can achieve higher performance than GPUs and can operate with fewer hardware resources, completing more work, thus reducing power consumption. Additionally, ASICs declined due to high custom dev costs, but development cost is a one-time expense. Data centers have high demand for chips, so mass production can amortize these costs. ASICs, which had almost disappeared, found a new footing once again. By 2023, AI development entered a new era. From robotics and autonomous driving to finance, all began to adopt AI technology. GPUs cannot meet such diverse needs. This gave ASICs another chance for growth. NVIDIA's GPUs have a 90% AI chip market share. Major firms are scrambling for NVIDIA's chips, causing prices to remain high. Take NVIDIA's H100 GPU as an example. One unit costs $25,000 to $30,000. To build more AI servers, Meta purchased 350,000 H100 GPUs from NVIDIA, with a total cost up to $9 billion. To cut costs and reliance on one supplier, the tech giants already doing ASIC R&D have all accelerated their pace, launching their latest ASIC chips. Driven by these major players, the global ASIC chip market continues to grow, projected to hit $35.5 billion by 2030. ASICs are not without their drawbacks. Besides high upfront development costs, ASICs cannot be changed after design is final. This makes them inflexible in the fast AI market. Thus, an alternative to ASICs appeared, FPGA. FPGA stands for Field Programmable Gate Array. During the chip development phase, engineers write HDL into the FPGA. This process is called programming, and field programmable means it can be programmed continuously. Simply put, an ASIC is like building a house with a mold. It takes time to create the mold beforehand, and once made, it cannot be changed. An FPGA is like building a house with clay. It can be changed at any time based on needs, molding the house into the desired shape. Also, because FPGAs can be directly modified, they don't need a detailed design process. This shortens development time. Generally, ASIC development can take up to 18 to 24 months. FPGA development, depending on complexity, ranges from a few weeks to a few months. FPGA's flexibility and short development time give it an edge with time-sensitive products. For example, in comms and medical AI apps, FPGAs can be seen in action. The rise of AI has sparked a new era for chips. Different chips are not just competing, they are collaborating. For example, in an autonomous driving system, the CPU handles vehicle control and decisions. The GPU handles fast image and vision tasks. ASICs or FPGAs accelerate specific algorithms. Different chips play to their own strengths, bringing more tech innovation to the world.